Auzu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Welcome to the online classes. Today we will discuss the exercise of chapter number 2. So in this exercise we will discuss first of all the conceptual questions. On page 49 you can see question number 1. Why sound produced by a simple pendulum is not heard? The answer is we cannot hear the sound of simple pendulum because its frequency is very low, even below 20,000, below 20 hertz. That's why we cannot hear the sound produced by pendulum motion. The audible range for the normal human ear is from 20 hertz to 20,000 hertz. So since the frequency is below 20 hertz, so that's why it is infrasonic, and infrasonic cannot be heard by the normal human ear. Question number 2. If a ringing bell, bicycle bell, is held tightly by hand, it stops producing sound. Why? When we hold our hand on the ringing bell of a bicycle tightly, then we stop the vibration. When we stop the vibration, there will be no sound produced. Question number 3. Why is the intensity of an echo less than that of the original sound? So original sound is its frequency is greater, and echo is the reflection of the same sound. So in case of reflection, the frequency become smaller. That's why it is less in magnitude than the original sound. In which medium, question number 4, in which medium, air and or water, an echo is heard sooner? The echo is heard sooner in water because the water is dense than the air, and the speed of sound in water is greater than the air. So that's why we heard a sooner echo, we heard a quick echo in the water than the air. Why sound cannot be heard on the moon? Sound cannot be heard on the moon because there is no air, there is no medium. So that's why we can't heard the sound on the moon. Similarly, another question. If a person places his ear on the rails of the railroad for determination of coming train, why is this done and how does it work? So as we know that the ear track is made of steel, iron, solid, and in solid the speed of sound is very greater than the gases and water. So that's why we place our ear on the railway track to determine the position of rail motion. Question number next. If the speed of sound is dependent on frequency, would music from the march band be enjoyed? If the speed of sound is depend on the frequency, would music from the march band be enjoyed? Yes, it is possible, because it is the musical sound is in the proper fashion, and we can enjoy the march band, the music from the march band, but it will not be as much enjoyed when it is in the rest position. So during motion, the frequency can be changed. Question number 9. Why does your voice sound filter in the shower? Why does your voice sound filter in the shower? Because the sound is filtered in the shower because another medium, the moving medium which is coming down, it disturbs the sound and motion. Question number 9. Why is it is so quiet after snowfall? When snowfall takes place, then we feel a very quiet situation, because there is a very less reflection of sound, because snow absorbs the sound. So that's why we feel a very quiet over here or there. Now numerical problems. Question number 1. The sound intensity 3 meters from the jackhammer is 8.20 10 power minus 2 watt per meter square. L is equal to 8.20 into 10 power minus 2 watt per meter square. L naught, it is a 1.00 10 power minus 12 watt per meter square. So the intensity level is we have the formula for intensity level. Is equal to 10 log I divided by I naught. Putting the values in this formula, you will get the answer in decibel. Or dB. Similarly, another question, question number 2. A ship is echoed where the depth of the water is 1.2 meter. Depth 1.20 meter. An ultrasonic signal sent to the bottom of the lake returns in 0.16 second, 0.16 second. Time 0.16 second. What is the speed of the sound in water? We have the speed. So for echo, we have the formula of speed is V is equal to 2D or 2, if this is replaced by D, 2D divided by T. V is equal to 2 multiplied by 1.20 divided by 0.16. So when we solve this mathematically, then so the answer is 15 meter per second. Not 15, but 15 meter per second. This is the speed of sound. If you use the mathematical expression, the answer, let's see the answer. .11. Okay, I think there is no answer in your book, but this is the possible answer. Similarly, another question is, what is the speed of sound in air at minus 20 degrees centigrade? Question number 5. Temperature is equal to minus 20 degrees centigrade. So we have the formula V is equal to 331 plus 0.6 T. T is the temperature. This is the formula putting the value 331 plus 0.6 multiplied by minus 20. So we have the answer. V is equal to 331 minus, that will be equal to 319 meter per second. So these are the questions, and this is the finishing of the chapter number next, chapter number 2, and inshallah we will start the new chapter in the next meeting. Okay, thank you.